Okay, so now that we actually have these pulleys installed, or these sheaves installed, now our work is cut out for us, because we have to do a few things. The very first thing is we're gonna do something like make sure that they're lined up, but also too, as far as our belt length, there is a formula in there in the book that we need to calculate and figure out exactly what our belt should be. So we're going to select the appropriate belt for that. But before we get into that, what we really need to do is do a similar thing that we've done before in the chains, or if you haven't done chains, this is the first time, we need to get our pulley alignment. Okay, so what are we talking about? Well, look, there is horizontal angular alignment with the shafts. There is vertical angular alignment with the shafts. And then, of course, there is just linear alignment with the shaft back and forth. And we need to take a look at all three of those to make sure that our pulley is going to, or our belt is going to track appropriately on the pulley and not cause premature wear. So if we have some misalignment, all right, and this is kind of forcing itself over here, and this is forcing itself over here, there's undue pressures on the side here, and it's going to cause premature wear, or possibly even the belt jumping off in the system. Belt systems are going to run a little faster than chains, so that is definitely a thing. So let's get started on how we get all these things lined up. Best way to do this is we can start out with a straight edge, and what we need to do is kind of sort of just touch on one side and the other side, and that right there will allow this to become essentially a broadcast for where this would go, where it would extend to. And what we want to do is kind of compare it to this over here to see how it lines up. Now, right now we can see an alignment issue in and out. So this is sitting out a little further than this. Let's go ahead and address that first so we can get a little closer. We may have to adjust it and then adjust it again, which is okay. It's not perfect because it takes a little extra time, but it's not the end of the world. So let's go ahead and make some of these adjustments very quickly. I'm loosening up the shaft collar in the back. This collar here, I loosen it, and then I'm going to rotate it. It is a cam lock, so there's two ways that it locks in, and then I should have a little bit of free movement with my shaft here. Okay, so now I can move my shaft. Obviously, I can move my pulley. I'm going to take this, line this up, and compare it to the other pulley. Now, I want to use the straight edge like this, because if I use it like this, obviously this is very flimsy this way. It's not going to give me what I need. So again, we're going to start to, there we go, right side. Use this as a gauge and compare where it's lining up. All right, now I'm touching. So one of the things that you may not be able to see is that my other pulley on the other side is actually very close to alignment. But what is happening is it looks like this exaggerated. All right. So what that tells me is I actually have a horizontal shaft misalignment. And so if it's out like this, then that means that I'm actually going to have to take my motor essentially and turn it this way, or turn my shaft this way to compensate for that. All right, so what I'm going to do is I'm looking down upon this, and I see it's obviously crooked. Again, it looks something like this, exaggerated. So now I need to make those corrections. So let's go ahead and make those corrections. I have a couple wrenches here. I'm going to go ahead and loosen up my motor bolts, because in this particular application, I decided that this is what I'm going to adjust. And again, it may be your output shaft or your driven shaft that gets adjusted, but in this case, I'm choosing to do this. All right. So I'm going to bump this around just a little bit. Then I'm going to go back, same deal, using this to extend this out and compare it to my sheave here. Wow, that looks really straight. So now I have a situation where when I'm holding this together along with the motor side, it is perfectly flat. So it's touching here and touching here simultaneously, which tells me now I actually have the horizontal shaft alignment. So very carefully, I'm going to go back with my wrenches, and I'm going to snug this motor back down. What I like to do is I like to work around with the bolts. What I mean by that is don't take one bolt all the way to torque at one time. And the reason I don't do that is because that can oftentimes cause shifting as you do that. So by putting a little tension all the way around, it generally likes to stay or allow the item you're tightening up to stay in that position as opposed to being jockeyed around. So bear with me just a second here. I'm going to go ahead and finish up with this tightening. And then after I get done with the tightening, I'm not going to just assume that nothing did move. Okay, so once I get around here and get this all snugged up, I'm going to check that particular alignment again. Okay, so I'm here, I'm going down. Yes, it looks the same. I'm going to bump this back some. I said we're probably going to have to move this again. And we are. And now I'm in perfect alignment. Okay, so now I have that. But wait a minute. What we did talk about is one more alignment that could be out. And that is the vertical angular distortion there. Okay? And how we can check that? We can check that in two basic ways. What we're going to do for this particular lab is either use this level here and compare this one to this one, or what we're going to do is use this square, or combination square is what they call it, and it actually has a level bubble in it. So what we can do is go against this face, or we can go against the outer face and look at where the bubble is actually lining up with the line. That's just touching the left line there in my orientation, and it is just touching the left line there. So I actually have my vertical angular alignment pretty good, but I need to check that because it's just as important as the horizontal. The vertical alignment will also cause premature wear and possibly the belt to jump off. Okay, now that we're lined up, now we can go ahead and begin to install and check our belt tension.